Good morning to everyone present here. Myself, Dr. Dileep Reddy, on behalf of Dr. Ramesh Naidu, Vijaya Shetty, Jyoti, Neeli, and Ramya Prakash, authors of this article. We are presenting with the article entitled An Intelligent Intrusion Detection System to Prevent URL Redirection Attack. So, in this work, first of all, I'd like to thank all the organizers and the editors for accepting our paper to this esteemed journal. So the agenda of this presentation is to brief you about the work carried out, the objectives, motivation, problem statement, project requirements and all, a proposed system with the system design, along with the implementation results and discussions, followed by the conclusion. So we start with the background of the work, what we did. So over the past few years, the internet has been leaping forward and a lot of systems have been developed for detection the cyber threats and detecting the malwares, and all the systems are pretty intelligent now. They try to uh, learn from the AI models and all that, and they try to improve upon. So the main concern here, what we're talking about, is on online social networks, where it's very critical for us to channelize or the people to connect, acquire the data, or disseminate the information and make friends and get entertainment. In this process of online system networks, the complexity of these systems are very huge, and they're in large scale nature, and they're in grouped with massive, rapid, and difficult traceability. We cannot find from where we're getting the information from. We are going to get some information, the social medias or social networks, but we don't know where exactly it came from. We click the link and it will open to the malware. We do not know. So that's what the background I'd like to give, and I like to emphasize upon cyber security holds an immense significance in today's digital landscape, where without that we cannot imagine how exactly this happens. Now, so due to this increasing interconnected systems, so this is a research area where we're focusing on. The key factors for the importance of this work, what we did is through rapid digital transformation, data breach and privacy concerns, and the other factor is economic impact and national state threat, supply chain vulnerabilities and ransomware attacks, regularity in compliance, and emerging technologies. And giving these factors, cybersecurity is not just a technical concern, but critical aspects of business strategies and public safety. The organizations must invest in robust cybersecurity measures, including the risk assessment, threat detection, incident response plans, and employee training. Finally, staying updated on the latest security developments to navigate the complex and evolving digital landscape. So the motivation of this work is uh, we would like to emphasize more on wide range of security threats what we get. The current system, the intruder detection system what we have, is effective enough to detect some threats, not every threat, but few of the other threats have they failed to detect, and the efficiency also is not so great for the existing IDS. It causes serious privacy concerns when it comes to organization or a person, and it leads to economic loss. So the motivation here is to propose a work and to design an effective ML based feature assemble model to detect the difficult or different attacks. So here is the work what we try to project. The gap here is, so when an attacker is going to, or a spammer is going to send a link which is going to be an URL, we're going to click that, it will redirect to an attack. So that's the main problem statement what we did, and most of the existing IDEs are not able to detect that. So we're able to do this with an increased usage of smart devices and increased usage of machine learning models. So we are trying to filter out these attacks, and with the help of different models, where it can be a neural network model, random forest, or extreme gratitude boosting. We call it as XGBoost shortly. So this is what we are trying to use and trying to find out what way it will work out to detect the attack better way. So the current methods will fail to detect the new type of attacks when you're getting it. And the performance of the classification is completely imbalanced with the data. So, so the problem statement here is, so the research work is mainly focused on to address and enhance the detection accuracy. The accuracy of the current systems are little low. We are trying to enhance that. That's first objective, what first problem what we are trying to solve. And also we are trying to develop an minimal time we are able to detect that attack by using improved XGBoost. We call it as IJEECS GB algorithm. How we are doing it? By using the optimizing the weight with respect to the imbalanced data and to detect the malicious attack more effectively. So this is a problem statement. Moving forward to the objectives of the research work. So the first objective, as we discussed earlier, we are proposing a machine learning model to detect the online URL redirections attacks in the network domain. Also, second objective, we are comparing the performance like accuracy, sensitivity, specificity, and computational overhead with the other models. So moving forward for the proposed methodology, say we have a system architecture design is existing like this. This is what is the existing model. We have NLS KDD data set from online public data set with cybersecurity to prevent the malicious attacks. We're using this NSL KDD data set. We're going to first do the feature scaling, followed by that attack identification using different machine learning models, result variations, ensemble learning, and set the URL that needs to be filtered out from the network. So this was the architecture of the current ensemble based IDE models for attacking classifiers. How we modified this architecture is, so until the feature selection we are intacted, then what we are trying to do is we are trying to split that to two sets. One set will move upon to training set, and we pass on that to improved XGBoost, where improved XGBoost will again select the features and cross validate this mechanism and send that as a feedback to the feature selection. And also it will give a feedback to the feature optimized model constructing through minimization of learning error. So this is the place where we are going to reduce the weight of the or optimize this method better. Again, one more set is given to training set from the feature selection, and that is being processed with feature optimization model, and then we get the performance study. So this is how we are able to do that in parallel processing, and we are able to detect the attacks in faster way and accurate way. So this was the proposed method what we have presented in this paper. Now project implementation, so we are trained all the classifiers. Let us say CI is the classifiers. We're calculating the first, second step is F measure score we are trying to calculate, and third is we assign the attack detection rank. So after that we predict which class or which row this corresponding attack is being done for the test of TS, and we are trying to find out from the attacks which is having the high ranked classifier, and from the high rank classifier we'll get the result in step 5. The results have been projected for the highest rank classifiers and are compared to the final result. So based on that we are able to get the best classifier for predicting the attacks. And finally the result, we call it as RCI, is predicted by the result of the classifier C of the sample I, and that is compared to check if that predicts the attack of the class XI. So if you take the algorithm 2, what we try to do is, if a match is found, so until the match is found we don't come to algorithm 2, we do with algorithm 1. If the match is found, then the conflict now, like if a conflict is found or no match is found, then the classifier results with the highest F mean score considered. Say we take R here. R is like your row in the training data, and TS is your predict the training set, whereas where we have R here, finally what we try to do is we have, say, A1, B1, C1, like that we have n number of rows we have. So and then correspondingly we have columns with A2, AN and all that. We are trying to find out AI, BI, CI from that corresponding function. Similarly, we have a training set also. From TS we are trying to find out the number of rows and number of columns with the A to Z. So finally, after the comparison, we are trying to find which row or which column we had an attack, or which row and which column we had a malware, right? So where F is the set of features in the data set, TR is the training set, TS is the test set, X is a set of labels that to be predicted, and C1, CT and C are the set of classifiers, and we also labels are the outputs. So these are the results what we achieved. The results by using the proposed intelligent IDS system trained with a novel feature called XGB. We compared with that with the existing IDS method and with a standard ensemble model. So the performance of this is as follows. So first, followed by sensitivity. Our model proposed with intelligent IDS is having a sensitivity of 94.8%. Existing IDS have 81.56%. So sensitivity is detecting the true positive rate. Then specificity is true negative what we have. So true negative also we are detecting up to 96.75%, whereas existing is detect 92.67%. We see the growth in the specificity as well. And accuracy of the system also is pretty much good for 95.47%, whereas we have an existing 86.78%. Accuracy meaning what we calculated here is model correctly classifies the attacks and normal with less misclassifications. So this what leads to a high value performance. Followed by computational overhead. Computational overhead should be minimal. The less computational overhead, that better the performance is. As we discussed earlier, the weight of the model is reduced, so the computational overhead is also reduced, and it classifies the overhead is taken care of, and the classification of the URL attacks can be predicted much better way in the compared present model compared with the existing model. Then finally, I conclude here with the work study of the various machine learning and models with the classifiers. And the result shows that the proposed model dependent upon the data set or detecting new type of attacks easily. This machine learning model is more effective to handle the smaller training data sets and can handle class imbalance as well in achieving the better performance ensemble of multiple ML models to build a new classifier to achieve better accuracy. So future work, what we try to do is we are trying to uh, do this model with different data sets like ISC, XID data sets, and any researchers can also work on with CIC, IDS 2000 data sets. They can work on that data sets as well. And the algorithms like light GBM also can be used, and histogram based models and gradient boosting also can be used to detect the multiple attacks. The researchers can do the work on this. We are also working on these models to find the high attack detection rates and low prediction rates using the proposed work. So I'll thank you everyone for listening to the presentation, and also like to thank Department of Computer Science and Engineering, Nitte Meenakshi Institute of Technology, Bangalore, affiliated to VTU, and thank you everyone for giving the opportunity. Thank you all.